Hello and welcome to Oscilloscopes Level 2. Let's get some questions. Right. Now that's interesting. 10% to 90% full time of this waveform. Now the full time is almost zero, because that's almost a vertical line. So I would tend to answer here 0. And that's good enough. That will get you the mark. Now, how many degrees of phase does the blue trace lag the red trace? And lagging means comes after. Time is going this way, so the blue waveform does indeed come one division after the red trace. Now, the period is 1, 2, 3, 4 divisions. So if the blue is coming one division, that's 1/4 of a period. 1/4 of a period would be 1/4 times a whole cycle, 360. That's 90 degrees. The blue is lagging. Next. Total fall time of this waveform. Well, that's the total fall time, not the 10 to 90% or 20 to 80%. So the total fall time of a symmetrical waveform like this is just half the period. The period is 1, 2, 3 divisions. So that would be 3 times. We're currently on 20 milliseconds per division. The fall time must be half of that, so 30 milliseconds. How many degrees of phase does the blue trace lag the red trace? And the first question you may be asking yourself is, what blue trace? And the answer is, well, there's only one place it can be, and that is immediately behind the red trace, which means they are totally in phase. 0 degrees of phase difference. Next. Total fall time, again, that's just half the period. The period is 2 divisions, so the fall time must be 1 division, 10 micro. 0 again. Just when I was thinking these are a bit too easy for level 2, what is the RMS amplitude? Well, you have to remember that the RMS amplitude is 1 over root 2 times the 0 to peak amplitude. The 0 to peak amplitude is 5 millivolts. So we divide that by the square root of 2, and that's how to write the square root of 2. So the calculator understands it. That should do. Yep. Now they're in exact antiphase, so that means 180 degrees out of phase. That's more interesting. The scope input is set to times 10, but the probe is set to times 1. So the scope is expecting the probe to reduce the amplitude by 10, but it isn't. So the scope is going to be trying to compensate for the scope probe and multiplying the reading by 10, but in fact the reading is not being divided by 10 by the scope probe. So the total amplitude on the scope is 10 times bigger than the actual signal in real life. The mean value of the signal, well, that's actually just 0. It would be 0 no matter what the scope probe was set to. Not as interesting a question as I'd hoped. Let's see if I can find one like that which is a bit more interesting. Here. What is the peak-to-peak amplitude of this signal? Well, the peak-to-peak amplitude is, according to the scope, 5 millivolts. 1 division and 5 millivolts per division. The scope input is set to times 10, but the probe is set to times 1. So the scope is effectively multiplying by times 10, but the probe is not dividing by times 10. So this is 10 times bigger than the actual signal. So the actual signal is 0.5 millivolts peak to peak. That will do for level 2.